Hello, everyone, and welcome to AI with Suhini, where we talk about everything AI. Today, I wanted to share with you my latest keynote to Swenode in Sweden. This talks about the journey of generative AI. Hope you like it. Enjoy. So today's topic, the goal that I wanted to share today is how enterprise solutions are changing, how they are modifying, and how even areas such as the financial area, like I mentioned, it takes a little longer for it to catch up with some of the other use case, some of the other domains, how that has evolved over time. So typically, again, this is back in 2020, late 2023, early 2024, when generative AI was just becoming understandable to most folks, and there was some tooling around. But again, there was a lot of myths that were going around that it is only useful for code generation. It cannot do anything else. It's very costly. When all of that was going on, the major understanding that was unanimous across everyone is you need a very powerful backend in order for the large language model to do its job. Think about it. It's a large language model can only be as good as the knowledge source that it has been provided. So that's the reason why there was a lot of work, especially at consulting companies at that time, to very quickly engineer solutions, and that required very strong backend analytical modules. So this meant we wanted to take a financial area or a financial organization within a large organization such as Accenture. It's 720,000 people globally. There's a lot of different global information that is to be shared. In these cases, there was a need to go from the diagnostic. Diagnostic means asking questions. We wanted to create a platform where experts could just come and query the financial health of the org. They could come and ask, how is my company doing? How is the market going for Northeast? How is it going for West? And of course, they should have access to the data first. But this was created for 20,000 users and across their different accessibility to the different database. But they could literally come and ask, how, what is going on? How can I, how is the status of the business in different domains. Then the next step after that was getting into predictive. How can I improve if the market is not doing well in West? How can I improve? And then finally, I want to get me the best idea so that I can improve my profit shares for next quarter or for next half. So it's very prescriptive. Tell me what I do first, tell me what I do second. And for all of these, we were able to engineer a solution in order to, and again, it was a personalized solution that would go to every single CXO based off of the access rights that they had. But again, as you see, it was an extremely complex problem that was chartered to me back in 2023, because especially decision making, it needs the right data and right inferences. You need to make sure it's context driven, because if you're saying that the profit margins are lower in a country where there are labor laws that are the bounding situations, you can't just give an answer that, well, get more deals and fire more people, you will get the profits up. So those don't work. So that's the reason why context is super important, and that's the reason why the best responses you would get when you have the right backend data connected to it. And finally, prescriptive and predictive trends and anomalies, finding those were the hardest ones, but now with agents, you can see that they have become super easy and beneficial to us. Let's take a look at the generative AI stack. And this is applicable if you want to have a Gen AI agent or a Gen AI application. It is unanimous and it scales. And these are typically for scalable enterprise level solutions. So you're not just creating a use case for yourself, doing your own taxes or things like that. When you are creating a solution that can scale across, as many users, so there is servers, there is network, all of that is at stake here. So that's the reason why you need to really understand and appreciate all of the different layers that are at play here. So first of all, there should be some guidance for production-ready environments. I mean, it's not that any use case can just be rolled out as is. So so that is the centralized. I was a part of that centralized guidance that was going around in Accenture in order to help any of the use case driven developers. So the first step is always the data layer, the multimodal, multi-schematic data. So as you can see, if you go to ChatGPT right now, or even if you go to Copilot, it can generate images, it can do voice activation, it can do, understand text. So again, all of the different components, the multimodality of the data that is at play. Then comes the very important data ingestion or the data embedding layer. So as we all know, textual data, it has to be, and like I mentioned, you have to get the right data into the LLM in order for it to do its rightful job. So that's the reason why there's a process of data ingestion. So let's say that I have a huge tabular data, or I have huge legal documents that need to be queried. Then in that case, the process is for there to be a backend system that is constantly creating embedded versions of this every single paragraph, so that in case that paragraph is relevant, then that is just fetched and then a response is generated on top of that. Then comes the generative AI model or the API layer. If we are doing RAG, which is retrieval augmented generation, then in that case, it is just how you are doing the API calls. Or if you are trying to fine tune the model, then it is you are fine tuning, API itself. And then there is a monitoring UI UX layer. You want to check if what is the health of the responses. Are all of them accurate? Are most of them not accurate? Is this a limiting condition that has literally, you have to re-engineer the platform for it? So that's the reason why monitoring the performance of large language models equally important, and also cost is another aspect as well. And finally, on the top of that, you'd see the generative AI app. So if you go to Meta AI right now, within your Instagram or within, WhatsApp, you know that you can talk to that. But all of this is happening in the bottom before you are actually having that conversation with generative AI applications. And same way, if you're doing a generative AI orchestration or an agent orchestration, all of these applications continue to be important. And again, there has to be a centralized use case monitoring, because like I mentioned, at an organization level, you cannot customize use cases for every single areas, but it is typically required to make sure there's a centralized monitoring, so that there is guidance that is provided at any point of time, like which large language models are useful for, let's say, mathematical areas, which are more useful for legal areas. So this kind of centralized source is a centralized monitoring source is super relevant for enterprise level solutions. Now let's start with some of the trends that we are seeing for financial domain going from 2025 to 2026. 2025 is the year of agentic generative AI, period. That's it. We've seen that from the beginning of the year. That was the theme very much. And now it has become so, anybody can have access to it. I mean, you can go to Meta AI, you can have a conversation, you can put a picture, you can get pixelated versions of you. You can use, Google's Gem in order to clear your calendar, to clear clutter in your Gmail. Then there is AutoGen by Microsoft. There is Crew.ai that does collaborative agents. So you can literally create your own set of agents. You can, enable a slew of them. Then there is Agent Light, Camel, Voyager, and so on and so forth. Now, the major difference between just a large language query, like we go to ChatGPT, we just ask a question and we get a response, and an agent is an automated entity by itself. So if you take a large language model and you give it a tool, an enabler to that large language model, then it becomes an agent. That's pretty much it. It's an LLM that has access to a toolkit. And what is this toolkit? Now, if you get an LLM and if you give it access to, let's say, your web page, or go to access your web, you can do a www, or you can go to Scholar page. You can do your search, or let's say you give it access to your Google Calendar, you give it access to your Gmail, you give it access to Google Drive. That is what an orchestration means. That means you take an LLM, you enable it to utilize that tool in order to do your search. So a very simple, instantiation of an agentic generative AI is if you give access to, a web page, web crawler, and then whatever question you have, it could be, what is the latest news today in US. So then the agent has the capability of taking that question and just putting it on the web and getting the information back. And then a second agent or a second LLM would then take this as a source and then prepare the response in the way you wanted it to be. So that's the reason why these are called agentic situations, where there is one agent that just went and crawled the information for you, and the second agent that took this information, prepared it in the format that you wanted, and then even stored it. So in this case, the second agent has access to maybe your folders directory, where it took all of this information and generated your reports for you. So 2025 is the year of agentic generative AI, where you can create all of this, toolkit. You can give the toolkit. You can give a very specific ask, and the agent can fetch that ask for you. Now, it is important to understand agents are not still capable of doing very complex tasks like decision making. That's hard. That is where the human intervention is required. Agents can do very simple short tasks. If you ask them to go crawl the web, they will do that for you. If you ask them to summarize something, they can do that for you. But if you are asking it for give me 5 or 10 options for travel, and pick the one which you think is the best, it's not able to then come up with these kind of rules. How do you define best? Is it the cost? Is it the time? Is it everything combined? So that's the kind of decision making where you still need humans. But again, this preparation of this initial versions of this travel package, that can very easily be done by agents. And now, trying to understand, where do you see 2026 becoming? Now 2026 is going to be where consumption or tuning is going to become super easy. So now, if you know some of the examples in Google Colab, it now enables fine tuning. You just have to get the library and you can fine tune any large language model. You can take the Mistral, you can take the llamas, and you can fine tune it on Google Colab itself for the use cases you are interested in. So the trend that is going towards 2026 is fine tuning. Again, will be super relevant, super easy, and also unified platforms and sources, because the one learning we've had so far is taking all of the different data together is the hardest part. So that's the reason why the way we store data has to be modified. And this way for this modified data storage, in order for it to be LLM consumable, that is going to be the area for 2026, where it's not just the financial domain, it's going to be the medical domain, it's going to be the legal domain, it's going to be all across all of these major domains of interest, where you will see this unification aspect coming in. Are there any questions at this time? I wanted to pause.
Nothing in the chat.
All right, and we keep going.
So Hini, Ylva from Malik, I have a question here. Can I speak it out?
Absolutely.
Yeah. So to your point, I mean, it is the year of agents for sure. But there's a lot of expectations on efficiency gains and, how can agents, support us in our daily work and cut 30%, become more efficient. How do you see upon that? How much of that is wishes and how much of that is the truth today?
Absolutely, and that's very much in point with the talk today. And this is again an extreme RAG approach that we took. But the first thing, whenever we were building any solutions for generative AI, for clients, they just wanted to use generative AI. The first thing we would build would be a checker, a hallucination score generation. Some way in which we can evaluate, is the response quality, is it high or not? And today there is something called the ChatGPT score. And the if you can just go and Google, what does that mean? It means if you have an LLM as a judge, which is taking a look at responses, and if you have instantiate this LLM as a judge for multiple times, let's say you ask 100 questions. Out of the 100 questions, how many times was it accurate, and how many times was absolutely bonkers? And in which case, what do you do in such situations? So the chatbot that we built at Accenture, there was this hallucination checker, and I'm going to describe what that was. And the major outcome for that was, if the score was moderate or low, then we wouldn't even show the response, because we know that it's not something that can be given to a decision maker at a financial organization. So the risk is very high. But then on the other hand side, any large language model, any agentic framework, the thing is, it's always going to come with errors. Nothing is 100% accurate, and it's never going to be. So the knowledge that, okay, it is going to be inaccurate, but there are ways of tracking that, and there are ways of using UI UX enhancements in order to say, okay, sorry, I cannot answer this question, but maybe were you thinking about this question instead of whatever you got access to? So there are ways of redirecting. So it is not, but you are also right that agentic approaches, if you don't check the usage, they can absolutely take off all your money in one day. Because if you do not put like a limiting conditions to two agents, getting you all of the information, they could literally get stuck in a loop, and this loop could drain all of your budget in one day. So that's the reason why it is still important that it's not a fully automatic process. There have to be folks who are well educated in these process of breaking these ties or breaking these loops whenever Gen AI agents do get into it. A very common loop that was in the initial days was called a gratification loop. That means if one agent is saying thank you, the other one would say, okay, thank you very much, or thank you back, and then thank you very much. So, and it would keep on going. And but then every single time you're sending this information to an LLM, you are draining your own money, right? So that's the reason why having these loop breakers, having these checkers in the process are super important. And then and I'm going to show some statistics, what are some ways of enhancing the performance accuracies just by doing some very small verifications or very small modifications to the way the agents have been set up. Does that answer your question?
Yes, thank you.
We have another question in the chat. I'm just going to read it out loud. So, if agents can execute tasks, how do you orchestrate them so that they also know when to start and when to stop? It's actually part of your question or your argument already, or hand over to another agent. But do you see any frameworks for that or standards being developed? Is that the checkers that you're going to talk about? So perhaps
what I will be showing is when you have the bare bones version where you are controlling for every single LLM query that goes into it. And then you can also have things like crew.ai or AutoGen, where you can have the number. You can say, okay, I want only 12 agents to be invoked, and this is the amount of budget, and these are some of the loops that I'd like you to break up in this format. So of course agentic frameworks have these considerations, but again, it has to be somebody who knows what are the limitations. But there are a lot of frameworks that are enabling rule-based agentic frameworks currently. So this is how the importance of a knowledge graph building with large language models. So typically, let's say that this was Accenture's report, earnings call report for a particular quarter. What would happen in the back end is all of the different nodes for the knowledge graph. That means the areas, the percentages, they would be detected and they would get tagged, right? And from a source to target, a sample knowledge graph would get generated. That means now you know how many nodes are going through a particular knowledge graph node. So this is what gets generated in the background. So whenever you have a document, you process it, you allow the LLM to go through it, it generates this knowledge graph in the background, right? But then what we saw was a web page along with knowledge graph along with LLM is the best combination for accurate non-hallucinated responses. And this was a study that we performed. So let's say that there are three instances. The first one is when you give a huge document. Let's say you have like a 200-page document. You just provide it to the LLM and you say, this is all of your context. Just give me all of the responses. So we have 100 questions, and we were asking questions from these 100 question stack. What we saw was that if we just had LLM only, in this case, only 25% of the responses were accurate. And then there were like missing data was around 50%, and the top 25 were hallucinations. But now we changed it when we said, okay, let's do one thing. We will have an orchestration, that is an agent who is first able to go and fetch the right data, And then that the right data only, instead of giving the whole document, I'm just going to first have an agent find out the right paragraphs or the right pages, and then only that data will be given to the large language model. In this case, what we saw, the accurate information, it increased. The number of accurate responses, it went to 50%, but also the hallucinations increased as well, as you can see. So that's where we said, okay, let's do it as a 3-part process. First, there is an agent, it'll go and get the data. Secondly, there is going to be another agent who is going to generate a knowledge graph. That means it's going to curate all of this information together. And then all of this curated information is going to then get passed to the large language model. And this is the only combination where we saw that the accurate information was around 70%, hallucination was still controlled at 25%, and the number of missing data was the minimal. So if you want to have an agentic or any kind of a generative AI, setup itself, then it is very important to know that for that particular setup, if the amount of knowledge is extremely vast, then the best approach in that case would be to combine web along with an agent that can generate a knowledge graph in the background, accurate knowledge graph, or which is vetted in this case, and then finally a third large language model, which is going to LLM call, which is going to collate everything and give you the response. So let's talk about these two studies, and all of these metrics frameworks will become more and more clear in this case. So the first one, this is a paper from our IEEE Big Data last year, and this is a generative AI architecture for from source tables. So if your data is purely tabular, so in this case, we were working with the sustainability team at Accenture, and what we wanted to do is they wanted to ask questions: which countries have the maximum scope 1 emissions and the highest carbon footprint? So if you see, it's a complex question, 2 parts coming together, and we were able to do questions such as what, which, where, compare, and so on and so forth. So first step was for us to do an intent classification and entity recognition, like what are the keywords that are going in there. And then what we would do is have an entity to data fetching. So this is where we used coding large language models. So it would generate SQL code in order to go fetch the data from the right source tables. And then this fetched data would be preloaded into BigQuery tables. And then this data would then serve as a custom LLM prompt, and then the generated response would be scored. And then again, finally, the feedback is collected, and the next question keeps going on, so on and so forth. Now here, what is the major problem? The major problem is you cannot ask follow-up questions. Like if I asked a question, which country had maximum scope emissions, and it give you, okay, maybe this particular country, and if you ask why, it will not know. It will have to again go to the previous question, combine both of them, and again this process has to continue. So you didn't save cost on your LLM query just because you have to do the same process or the same data fetching again. But now we had a way of aggregating these tables, in which way we were able to control for cost, so that if you had follow-up questions, it would not have to fetch the data again, but it would be already from a pre-fetched data, aggregated data, which would be reused over and over again. So let's say in this case, it was a finance domain query, and we asked which market unit contributed to the least in sales last year. Again, the first step is intent classification. Is it a what question, which question, how to question, so on and so forth. We did an intent classification, and then this whole question was embedded. The embedding, again, using ADA embeddings or BERT embeddings, ideally, but ADA is supposed to be way more powerful. From where we go to the prompt selection, and from the prompt selection now comes this custom process where you had a lot of tables in the background. These tables were read, and a table to sentence generation was done. And these table level summaries of sentence, so it's like paragraph, it's an LLM, it's taking a look at the table, and it's just reading out North America had 36% profit in Q4 of 2024. So things like that. It was just generating sentences, and these table level summaries and data chunks were embedded and stored. So you see, this becomes a whole offline process which is constantly reading and replenishing this knowledge base. But once you have this whole pipeline of crunching through the data, now your life becomes super simple, because only the relevant data is fetched, put into the custom prompt, the Gen AI response that is generated, and now you can ask a follow-up conversation. Why? Because a lot of data is already fetched, and only a few little part of it might be used for your response, but the data is already pre-fetched. You don't have to reload it, you don't have to refetch it. That's the reason why larger conversations now become available, and I'll show you an example of how these larger conversations work. So now if we have to take a look at what a typical RAG prompt would look like. Now, prompt engineering, I know back in 2024, it was like a super relevant, it's a chicken egg problem. Some people say, why do we even bother with prompt engineering? Because I can just ask the large language model to generate the best prompt. And then you again also know that, okay, you need a good prompt in order to get a good response, right? So again, which one comes before? The answer is you definitely have to know some basics of prompt engineering for your, at least to get a starting point. Otherwise, relying fully on the chatbot to get a good prompt right from the get-go, right from out of the bat, is a little higher expectations than what you're going to get for. So understanding that a good prompt has all of these sections. It typically starts with a header where you give it a persona. You want it to be very succinct. You don't want it to be like a news reader. You want it to be very point-wise, tabular, or do you want it sentences, all of that. Description of all of the metrics and the keywords that you expect the LLM to be understanding. One of the early examples was when we were giving data on SAP, it thought it was confusing it with tree sap. So that's the reason why if there are specific metrics, they have to be introduced. All the relevant data chunks that I just mentioned, the aggregated data chunks are available, and the instructions on how you want them to be used, and a sample question and answer format that gives the LLM the confidence that this is how you are expecting your response to be. So in this case, the customized prompt generation that we had was, did profit margin decrease for healthcare? Again, the first part is when you're giving the persona, then you're giving the context, the instructions, and the example. And then the final response that comes back is no, profit year over year increased for healthcare by, let's say, X%. And here, this is where we have the generative AI control purposes that I was mentioning a while back. So what we did, we came up with a set of metrics, and these are the metrics that we are utilizing to understand the quality of the response. And every single response, I'm not taking like a statistic at the end of the day, but I am really looking at the quality of every single response. So the first thing is the contextual, accuracy. Contextual accuracy is if I asked you a question about North America, do the context or the data that was fetched, is that North America as well? Or was that about Europe, completely different? And if the response, so we take a look at the question, we take a look at the context, and we take a look at the response. It's a triad that is now evaluated for the context through and through. And then comes numerical accuracy. If I asked you, about a particular number, like give me the profit margin, is this number available in the context itself? If the answer is no, then there has to be a modification. There's a high chance that there is a hallucination. Then comes uniqueness from prompt. That means this is where we gave it a specific way to see, is the large language model, at least rewording things or not, or is it just reading off from the script as is? And finally, sensibility. This is something we saw very early on, is for finance domain. The sensibility around LLM responses was a little low. That means if you say, the market increase, there was an increase value by negative 12%. You cannot have a negative 12% increase. So that's the reason why with terminologies, we had to explain sensibility. So ideally, in this case, if all these 4 flags were 1, or if all of them are accurate, then we say it's a high quality response. If any one of them is 0, we say it's moderate quality. And if 2 or more are 0, we say it's low quality. So every single response that would come, we would have these 4 checkers to see how the quality of this particular response was. And for any response which was not high quality, we actually surpassed it. And we say, can you ask it again? Instead, do you want to ask something else? Because we wanted to make sure if it's decision makers, it's only accurate responses that are going out. So in the same way, there are a lot of LLM as judge and a lot of agentic verification approaches that have also now started. So the idea is the same. You have a response, ask an LLM to go check it. This triad, it just goes, does that for you. But again, if that agent is wrong or was the first response wrong, you don't know. That's the reason why having a little more controlled approach, as we mentioned here, is sort of more scalable to go. And again, we were benchmarking through across a lot of large language models just to make sure, the accuracy stayed. So this was a sample enterprise level conversation that we had. Was if the user was asking, what are the profits from last quarter in North America? And let's say the chatbot answered, well, the profit was X%. Then you ask a follow-up question, is that high or low? But now we don't need to refetch the data because we already have the data for North America, Europe, Asia, APAC, everything put together. So it's just scrolled through that information, and that's the reason why it's able to say, well, it is high. And then if you ask a follow-up question, which is why, it can now give you the context as well, because all of that data was already prefetched and stored in the data set. But now if you ask a question which is a little more thought-provoking, what is driving profits? Now in that case, we came up with this canned response that, sorry, I don't have enough data already. Can you ask like a full question? Or in this case, you will have to compound all of the questions together in order to make a better quality response set. So all of this orchestration that was happening in the background, that we were actually controlling for it rather than letting an agent do that. So the only change now from the time we built this chatbot system up was now all of these modifications the agents are able to figure out, and they are able to make the decisions. But again, you run in the risk that what if there is a loop, what if an agent is off. That's the reason why for the financial decision making chatbot that we built, we actually curated all of these steps rather than relying on agents at that point. In the interest of time, I'm just going to go through the next work. I think that's pretty interesting, and then we can take more questions, I hope. So this is the other paper. Again, we submitted and we got it published in IEEE Big Data last year. And this is about fine-tuning large language LLMs, LLMs for financial domain. And here the goal was financial report generation. So the writing style of a financial analyst is completely different from that of general English. And that was the major goal, that can we do style transfer with minimal cost? So the budget that was given to us was $20. We could not use more than $20 in order to do the style transfer or to come up with this automated report generation framework. So what we did was, can we utilize some prompts and textual data to train the large language model, use RLHF, and then the goal is to generate financial analyst data quality. So here the hypothesis that we came up with was, intelligence requires the capability of learning from mistakes. So you have to let a large language model make a mistake, and then you have to explain that mistake in order for it to understand what to do better the next time, right? Because there is a fine line between creativity and hallucination. And that was the fine line we were trying to come up with. So the solution was, let the LLM hallucinate and explain its errors to it. And then this promoted the creativity as a part of a two-step process. And this was actually our work. So it's not a three-step process, not a one-step process. It's a two-step process. And it worked like a charm. So let's say the sample prompt that you want to do for your intent report generation is, this is your tabular data, and what you want is generate a financial report for a company based off of this data. And if you see the sample prompt to intended report generation, there are compound sentences where you can say, okay, aerospace did this, however. So there are these however that change the intonation. So there are compound sentences along with creative sentences that you did not provide at all. Like the positive margin is indicative of operational efficiency. How did you know that it is indicative of the operational efficiency? Because it is now able to learn from its mistakes and generate creative responses by itself. Now, what was the process here? In this case, the data preparation was the crucial part. So you take some manual, reports. From these manual reports, we utilize the LLMs to generate, different comps. So it's like, if I have, this is my report, this would be the prompt it came from. So we are reverse engineering the problem. So that was our data to begin with. If you have manual data, manual reports, we are coming up with the prompts. And once the prompts are there, we are fine tuning it for, let's say, the header, the introduction section, a separate prompt for the base, a separate prompt for the conclusion, and also for different kind of personas. So if we take a look at the quantitative scores for the two-step fine-tuning process, so these were the different metrics that we took a look at: the blue score, the rouge score, the ter score, all of them. And what we see is for these, the fine-tune for hallucination, that the two-step process, that's the green bars, as you can see. Green bars are always high when compared to the non-trained part of the LLM. So in this case, we also took a look at like 100 questions, and these 100 questions were just given to the large language model, and we see, okay, if we just had a single step versus a two-step process that we mentioned here, we were able to see the same trends as the knowledge graph, and along with web page and LLM that we showed at the beginning, where we saw that the number of correct responses just doubled, and also the number of hallucination, they absolutely fell off. So around from 20, they went to 7. So this, we understood that explaining and enabling the large language model to hallucinate, and then explaining from there, was actually a better scenario. And every single time you were allowing it to make an error and you were explaining what went wrong, you're actually helping the large language model to get better. At least the agent instantiation you had to get better. So what we saw is the training steps, as the training steps increased, the confidence in the text generation kept going up. So in this case, the monitoring for knowledge density, what we were looking for is a lot of information in a few number of sentences. This fine-tuning required a lot of preparation of data, and also this, we were able to achieve this in $16. I wanted to leave with some of the major directions in which generative AI solutions for finance are going. The major thing that this generative AI agentic instantiation has done is it has reduced the amount of time of initial delivery, right? So your UAT or coming up with the MVP can easily be done within 6 weeks to 8 weeks right now. But then the predictive, the personalized control, the quality control, the breaking of these loops, as I was mentioning, that takes a little more time. And that's where from 2 to 6 months, finally going into 12 months is where you're seeing maybe another new version of a llama, maybe a new version of mixture of experts. And this is something that is very close to my heart. So I always finish with this slide. This is how generative AI is going to change the industrial data completely. First thing is dashboards. As you can see, dashboards typically used to be generated by Power BI, Tableau experts. Now, generative AI can just do it. You know exactly what's required, and it will spit out the code. You can have your dashboard in few minutes. Business data definitions. This is the way in which the data is being consumed. And this is where I believe in 2026, a lot will change in the way the data is stored itself. Like these definitions, like I mentioned, the SAP or the SAP, these will by default be stored in the backend data. So the consumption by LLM is going to become much more easier. Then comes data management. So human data checks. Is there a quality control? All of this can be done very easily using large language model. Then comes unstructured data. So you have so many multimodality unstructured data, bringing more context. That is something that will continue in 2026. And finally, data access, making sure that granting access, having access to the right data sources, that is security checks, all of that will continue to develop in 2026. So I will leave at that. I know I went a little over time. I would love if there are any questions.